Okay, we're beginning a new chapter today, linear systems. Unit essential questions that you need to have in the back of your mind and be able to answer as we're going through the chapter. How does representing functions graphically help you solve a system of equations? And how does writing equivalent equations help you solve a system of equations? So in this first section, we're going to be solving systems using tables and graphs. So by the time that you are finished with this lesson, you'll be able to solve linear systems using a graph. First of all, there is a warm-up. All three of these equations I want to see graphed on the same coordinate plane. So use just the one plane for all three graphs. Pause the video and work these problems and then come back and check your answers. So this one we know crosses at a -2 and the slope is up 3/1. This one has a negative slope, goes through 0, 0, and it goes down 1, right 1. And this one crosses the y at 4. It has a negative slope, down 1, right 2. Our key concepts for this lesson: a system of equations is a set of two or more equations that use the same variables. A linear system is when the graph of each equation of a system is a line. And then the solution of a system is the set of values for the variables that makes all the equations true. It's also known as the solution or the root or the intercepts. So our first example, we're to graph both of these equations. Notice they're linear equations, x is to the first power. So we're going to graph each line. This one's going to cross the y at 0 because it's our plus b is there's nothing there, and the slope is 1/1. This one will cross the y at a 2, positive 2, and its slope is 2/1. And this intersection point where they both cross each other is at -2, -2. So the point of intersection is the solution to that system. Okay, there's something we're going to have to do here first. We're going to have to solve for y. You want to take a moment and do that? So we're going to graph each line, and then the point of the intersection is the solution to the system. Add 3x to both sides, divide every term by 2. We will see that it crosses the y at a positive 4. And our slope is going to be 3/2. Positive, up 3/2. This one, if we subtract x from both sides and divide every term by 4, we're going to cross the y at a -3, and our slope is 1/4. They intersect at -4, 2. So that's going to be our solution. Okay, other key concepts. An independent system is a system that has one unique solution. Now, not every system of equations has a solution, but they will have intersecting lines, and they will intersect in exactly one place, and their slopes will be different. So that's how you can recognize it algebraically. A dependent system is a system that does not have a solution, a unique solution. So in other words, when you graph the two equations, they're going to be the exact same line. So it's the same slope, same y-intercept, everything's identical. And then they're inconsistent systems, so that's a system with no solution. Parallel lines, they never intersect. So they have the same slope, but different y-intercepts. So this one's independent and consistent, or you could be dependent and consistent, or it could be inconsistent. So let's look at this example. The first thing I'd start by doing is rewrite each equation in slope-intercept form. So we add 6x to both sides, and then we divide every term by 2. Well, look at there, would you? Both of those equations are identical. So what do you know about if they're the exact same line? They are dependent. So it'll be consistent and dependent, because everywhere you graph for this one is the same for this line. Okay, so let's classify this system without graphing. So let's write each equation in slope-intercept form. Of course, we're going to add 2x to both sides, then divide every term by 4. On the second equation, we're going to divide every term by 8. So let's look. Same slope, different y-intercept. What does that tell you? Why, they're parallel lines, aren't they? So they are inconsistent. They will never, ever cross. Okay, you're finished with the lesson for today, so it's time for you to begin working on the assignment. Good job.